going to open it up to questions. Anybody here on the floor? There's one.
Yeah, interesting. I'm not sure I got how you analyze the video, visually, or you transcribe it and you analyze the text. If I understand, I mean, using deep learning to do image recognition isn't that accurate still. So video should be harder. Are you trying to, from the visual frames, understand what the video is about? Is that what you're doing?
Yes.
Ouch.
We're having different models. We're having spatial and temporal models, and this is currently only based on visual features. We, however, output transcripts for our customers because they often want it.
Other questions from the group here?
And sorry, just to complete. So in current experiments on topics, the transcript doesn't seem to help very significantly. So I'm going to be cautious on that because we're still experimenting. But the transcript doesn't help very significantly compared to our visual features to classify.
It's worth saying that in the last 2 years there was huge progress on this quality of.
Right, we're pretty research-oriented company. We're 11. Half of us are researchers from an academic background. Yeah.
So you're saying understanding the aboutness of a video, what is it about, visually is more accurate than the actual transcription of the video?
Yes, that's correct.
So what about a news clip? What about a news clip? All you see is an anchor woman or an anchor man saying something. Visually, you don't get what is it about. I mean, because this is to me science fiction. Visually, you can get what is it about more than the actual text.
Well, so of course in this example, I think it's pretty clear.
Or an interview. Or
it will, as you say, it will definitely depend on the kind of video we have to analyze. So I'm talking in general, but yes, text is relevant, and that's why we're experimenting with it as well.
All right, thanks.
I do not agree. It depends on the type of material, yes, but I think the semantics is more transported with the text, with the spoken text. So we have worked in this domain too. It depends on the domain. Yeah, but in the news, this was a good example. If you see only the anchorman, the texture does not say.
I am talking to news people, so I shouldn't have talked about it.
Yeah, I was just going to point out that what I'm seeing on the screen in the background isn't news video; it's video of a soccer game, and the transcript would be meaningless. So that's an example of where the visual is conveying the information.
But in this case, this is more like an image recognition than content recognition. I mean, there's no content. Yeah. So that's why I guess the technology of deep learning. Okay, you're recognizing an image more or less, and basically all of this game is one image, which is a soccer game. There's no content.
I actually disagree. Someone scores a goal. Someone has a foul. There's an offside. There are lots of things that happen.
These are not visual. I mean.
Well,
but they're not spoken.
They're not spoken. But
all you get is a soccer game. What I'm saying is text tells you the actual facts.
Well, no, I disagree. I was at IBC where I saw some technology that allowed you to analyze a video and allow you to move to certain points in that video, say a 30-minute video, and you can go to that person smiling, that person happy. The technology is moving on, and I sent it to Andreas earlier, but I don't know if anyone's seen the trailer for the film Morgan, Ridley Scott produced film that was out a few months back. The trailer was created by Watson, IBM's AI, 100%. And if you watch it, the trailer looks like it was made by Hollywood's standard trailer production company. You cannot tell the difference. So the technology to work out, you're watching a soccer game, that's a goal, that's an instant, that's a foul, and getting emotions out of it is coming.
No.
it's going very quickly.
I know what some people who work in AI, I know the state of the art, but you can get visually who scored the goal.
Let's get this conversation back to the panel and continue this conversation perhaps after the panel. It's an interesting one, and it certainly comes down to what is the value that you're trying to get out of the current application of a certain technology. So, for example, if you start with a video like a body cam video from police, where there is certainly no transcript, figuring out what is happening in there and what this is about and what you're seeing certainly provides significant value to whoever has to go through it first. Are there other questions for the panel?
So with Cumulus, or actually, I think most of the products have been around for a while. I was wondering if you could just talk about some of the really big changes over the last 20 years for your product, different things you tried to tackle or focus on.
In general? Last 24 years. I mean,
In big chunks.
I need to refer to Scott, because he actually built something like a pipeline where we are heading to, and that started with text. And I made a similar presentation 10 years ago. Started with text being digitized. Text was the first to be digital. And then there come black and white images, then there come color images, now there are videos, VR videos. But still, videos are not the real thing. If you look around, this is all 3D, and it's all live. And we're not even getting close to the real world. Although we have lots of media, we are still on the way to the real environment. And this is the ultimate goal, I guess. We want to have media that looks like the real world, really not VR. I mean, you still have those glasses, and that's ridiculous. I want to have things around me that look real. And we will maybe I'm too old already, but maybe some of you, being younger, will develop something in the future that brings us there. So the evolution of media over the last 20, 30 years was adding more and more value to it, more reality touch to it.
So you're saying what you really want is a holodeck.
Right,
okay.
Exactly.
Well, as the resident old person here, I would say one of the things that we learned in this process, because we've been through all of the stages of grieving, if you will, we've been through all the stages of developing these platforms, is that you have to build the platform in such a way that it will accommodate whatever the next great thing is. And, you know, the nearest in next great thing that I think we all see and we recognize is VR or AR. But there's something beyond that. And so in building or buying a platform, I think it's very important that you're buying one which which is modular and extensible as well as expandable. So it needs to both be able to get bigger, but also it needs to be able to accommodate new media types flawlessly and simply. So that's my perspective on sort of what at least I've learned in the last 31 years.
Others?
I guess I have a variant on that same question. I'm interested in whether in that long evolution of at least a couple of these products and companies, you've seen more fragmentation, more diversity, or are you seeing more convergence toward standards?
With regard to standards specifically or generally?
With regard to formats, metadata, et cetera, do you see a trend on converging on standards, or do you see a twigging happening in your world?
Well, I don't want to be driven out with pitchforks here. in terms of fragmentation, we are certainly seeing dramatic fragmentation right now. It's the story of the last 20 years in this industry. We're seeing fragmentation in terms of who is creating the content and how it is being delivered, how it is being consumed, and by whom. I mean, the whole story of this revolution is a story of fragmentation. Now, that being said, with regard to standards, it reflects that last concept. I would say that of our development staff, given the fact that we integrate with so many different providers of content, 40% of the developer hours that we spend at Mainstream Data are spent adapting to, manipulating, conforming, consolidating metadata from supposedly standards-based metadata. Literally, almost half of our development hours are spent with this person's version of the standard versus that person's version of the standard. Is that getting better? We haven't seen it yet. You know, we hope that it will. But Bloomberg and the New York Times and Reuters and the AP, well, I don't want to speak for the AP, but they all have slightly different variants of the same standard, and it still requires a lot of developer hours to work around that.
Yeah, let me just point out that this is a classic example of the feature or bug issue. Because as standards get more and more expressive, they enable actually greater variance in terms of implementation of that standard. And I see this all over the place. If a standard is inexpressive, it's easy to get everybody to doing the same thing. But the more expressive the standard gets, the harder it is to make everybody use it the same way.
It ceases to be a standard in a sense.
Well, it's a standard,
right?
But it doesn't enforce conformance in the same way.
Well, and nor should it,
right.
In all fairness, right?
It's made for the expression.
Just a simple side note, we completed about a year ago a project for Microsoft, for MSN, for their 2,000 editors to acquire content from about 200 different sources around the world, which required us to build an integration via API in most cases into 200 different sources of content. So, for example, into Getty, into AP, into Newscom, into the Pakistani press, and so on. And then bring it into a single consolidated display for end users. You know, that was not a minor challenge. The hard part, however, was integrating into the standards of 150 to 200 different providers, even though they were all supposedly living by standard.
How about the other system providers? Is that something that you equally encountered? Is that
well, we had the same experience with file formats. So if it comes to file formats, even image file formats that are very old, like TIFF, I would say that 70% of the TIFF files out there are just not according to standard. And if some vendor is writing a TIFF file and he's testing his software he's testing against Photoshop. And Photoshop is so flexible of reading any wrong TIFF file format that they easily pass the test. So still it's not TIFF. And I think that's quite the same. Maybe there's something missing, like a validation software, written in software and rock solid, provided by the standards body, maybe, or some consultancy company, so that you can prove that you are following the standard. And there are some attempts to doing this. And for example, the XMP, as far as I know, we're using the same library as everyone else in the world reading XMP, and that makes it very consistent. So whatever the library, and Adobe is providing the library, even in source code, although not very readable, but that allows to standardize on XMP and make sure that as long as Adobe is consistently providing the latest version of that library and fixing all the bugs, that everyone is using the same XMP. Maybe that helps.
Talking about the changes that you mentioned over the years, I can actually talk about some reality that we had with our software. About 2 or 3 years ago, we realized that Scott already said that we get more and more data over the internet, and we found out 2 or 3 years earlier, the hard way, that file sizes changes a lot too. So it's getting bigger and bigger and bigger. So at that time, we actually had to trash our database model and start from scratch new again. So we're not using a database model anymore. We are using Elasticsearch, which is not a database in that. This is one of the changes that we saw over the years. And I don't have visions, but sometimes I'm afraid of other changes that we have to follow in terms of development.
That's a fact of life.
I'd just like to follow up on that point made a little earlier about different providers. Providing different variants of the same standard and claiming it's the same standard. On the flip side of that, I'm putting this to the vendors for their response. Over 20 years in the business, I've had a lot of promises from vendors saying, yes, we support these standards. And what they actually mean is, yes, we have a regex, regular expression engine, that rips maybe 20 name value pairs out and store that in string fields, and maybe they can write them back into some things. Is that changing yet? When you say you support the standard, are you actually storing stuff in the standard and indexing it like that?
Me? Okay. When do we start talking about supporting a standard? That's a difficult question, and it's more marketing related than actually development related, I guess. Well, you need to have some good material to play with. I mean, as a developer from the heart, I really want to write my program as good as possible. So I want to have a good test environment to test it against. Unfortunately, most of the times, you don't find any test material. Maybe you get it from one of the customers, maybe 2, 3 customers, but there's not a pool of test material to test against. So when is actually the point that we can say we're supporting the standard? As I said, with writing back the standard, it's easy to suppose you're according to standard. You're writing the standard because no one is reading it. There's no proof. When reading, you may find 1, 2, 3, 4, 5 examples, but that's it. And that is one of the problems, that you cannot actually test against a good variety of variations that are still standards conform. So for the standards body, that could be the request for getting more material out that is following the standard, but hopefully in a very wide range of variations, so that we can test the software as well as possible.
I think we're all correct here. Which is, we're doing the right thing as an organization by creating standards which, although they're not legally enforced, move people toward a common objective. To tell Reuters, or to tell the AP, or to tell Getty, or to tell someone else that, no, you have to live with a strict format and you may not vary from it. Might work in Germany, I'm not sure. But it certainly would not no, it wouldn't. But it's not realistic, and it doesn't need to be, honestly. But to have everyone walking down the same lane, although one may be on one side and the other on the other, is certainly a step forward. I don't expect in my lifetime, or in Francois' lifetime, that we will get to the point where the same ingestion engine will be able to deal with all different types of content, nor should we. It's a point of differentiation for the vendors. The people at Getty think they have better metadata because it includes these fields than the people at Reuters. And that's fine, and that's good. and it may or may not be true. but we're going in the right direction, and it's okay to take a third path. My perspective. It also is good for my business.
Well, Thomas, you have also already answered this question. My question was, would it help system vendors if a standardization organization like IPTC would provide some reference items?
Definitely.
Yeah.
Definitely. Having a test suite of a lot of material, the more the better, would help us a lot in testing whether we're complying or not.
And just I'll add one other observation that I see the standard as possibly being useful for those organizations in terms of how they store and characterize their own information and their own content. But the main purpose of the standard is for interchange. So it doesn't necessarily need to mandate that Getty does things the same way internally as Reuters does things internally. But when they exchange content with the outside world, doing it in a standard way is what takes the friction out of the system.
Minimizes the friction.
It doesn't eliminate it, but it minimizes the friction. That's really, I think that's one of the main values of the standard, is the interchange value.
Yes, there's another question.
Just a quick question for Francois. So you have this experience, right, with extracting content from videos. So what are the limits of today's technology, since you are, let's say, in the field, and also comparison, let's say, to what Google is doing with, at least the demos they're showing, they're incredible, right? I'm not sure how this is scalable and how complex classes they can detect, but at least the examples are impressive. Some of these Google engineers are showing, right? So what's your field experience with the quality which is possible to extract today?
So the first thing to say is that the field is evolving super fast. That's incredible. So I can read like new papers that are coming on video extraction. It's like reading the newspaper every day. So every day there's a few algorithms that are techniques, methods to improve some of the aspects, maybe training speed or detecting small objects that are usually harder. So Google came with TensorFlow, which is a new library, which introduces a small revolution that makes that you can parallelize as much as you want the training. So now you've got Amazon cloud, and then you get as many machines as you want, basically. So that also helps. Then, okay, that said, there's a difference between results in academic papers in controlled environments, and so controlled data sets, and then what you can get into production with customers' requirements. And so specializations in some verticals, for example, or customers not wanting to output something, et cetera, et cetera. So, well, that's what we're trying to tackle, more than building the super model that no one came up with and that learns better than the others. We're more focusing on the infrastructure around learning and specializing, giving the ability to specialize.
How useful you can be, like, for news publishers at the moment?
How useful can I be for news publishers? Yeah. So, thanks for that. Thank you for your very useful. We'll solve all your problems. So, seriously, we're doing currently good at being able to take raw video content and then providing some metadata to make it searchable. Okay, that's where we're good at. We're not yet ready to trigger alarms when something happens on a security video, because our precision recall is not good enough for that. That's the best answer I can give. Our customers are happy.
Right. So the value that you guys provide, and I can speak to that because we actually looked into it at some point, is basically if you have a completely untagged mess of videos. If you have a lot of content and there's nothing on it, no information around it whatsoever, to get a good starting point.
Also, what we do is we can replace your expensive team of manual annotators. That, you know,
it's a social problem.
Well, it is. But other questions somewhere in the room? Nope. Do you guys have questions for one another?
I would have a question for Francois, because I'm in the business for a while and I see companies popping up with image recognition, and I get the feeling that you need to have some wave of new technology being introduced, and there pops up a new company with a new technology in place, and then they struggle with making this a product and putting this into place at customer side. And for the next years, they're concentrating on building around it, but the actual algorithm has never changed, or maybe improved slightly. But the basic algorithm is still the same. So they're not taking a complete new approach with new technology popping up 5 years later, because they're still involved in all those customers. Is that true? Is that feeling that I have true, that you have to wait for another 5 years for a new company to come with new technology and then they start over again?
So if I understand, if I understand your question correctly, I will disagree, because I think deep learning has experience is a breakthrough. It's a technological breakthrough that 5 years ago wasn't at all what. So the achievements that are now compared to 5 years ago, it's very different what you can achieve.
What happened to the companies that had image recognition 8 years ago? Did they actually now use deep learning to implement what they did with other technology before? Do they really shift to new technology, or do they just improve it slightly?
Yeah, so that's before machine learning. So yeah, so
they got acquired.
They got acquired. So one fundamental difference is traditional machine learning techniques. You had to manually design the features. So for your domain, you had to say this and this and these features are relevant for me to build a good model to learn that kind of features. Deep learning gives you more flexibility because the system itself will decide on the features, so you can more easily switch between different domains. So you mentioned me the example of audio headphones that were very specific. One of your customers is want to search over a collection of videos of audio headphones, and then so there you would have. Before, you would have to design specific features to recognize headphones. Now we can train a model that will learn what these features are, and this will take less time, hopefully.
So I have a question, which is, with the flood of video that we're seeing, right? I mean, I don't think anyone would argue that there is a flood of video which is becoming available in large part because much of it is user-generated video. What are the implications for the required processing power to manage that? I mean, if in fact there is an algorithm which adds some real value to video, how specifically we don't know, but what's the processing power required for that? And haven't the security agencies for various countries already done this stuff?
Well, I think an interesting, I'm sure various security agencies have done this stuff and just haven't told us about it. But leaving that aside, I think an interesting question is if you just look at the evolution of iOS as a software and the hardware that it runs on and the features that it now provides you in the built-in photos and video apps. Is it great? Perhaps not, but it's certainly much more than any standard PC could have done just a short while ago. I don't know what processing power Dextro requires, how fast you can analyze videos. But
yeah. So currently, analyzing one video takes about half the time of the video. So it's still quite a lot for one process. But this is completely parallelizable, of course, and using cloud technology, we can theoretically scale as much as we want. The thing is that as the research evolves pretty fast, constructors, the hardware also evolves quite a lot, and there's a lot of effort that is done on doing computer architectures, processors that are specialized in these things. And so this is evolving very fast, and we already see like new NVIDIA is a graphical processing unit, a vendor, and they release a card every 6 months, faster than you can buy them.
Yes, I've also an answer regarding this question. So I think there's much more video recording as we can see in the web, because if you look at all the frontiers in the whole world, and all the policemen and persons running through the streets, they have cameras. And these cameras are intelligent because you mentioned already they have inside the processor. They only can recognize certain situations, and they only transmit if it's interesting. And if it's interesting, then you have human beings or other algorithms to analyze it. And everybody knows who pushes this technology and research. So I know, for example, from Israel, they had this problem that they have these frontiers and so few people to control it, then they were first to find these good algorithms. And when you see this examples in the first video recognition, you have the impression this were Palestinians who jumped over a fence and they could recognize it. So this drives it, and I think the NSA, they do a lot of research in this domain, because we have so many, if you have all the policemen and people running through the streets now at demonstrations, at critical situations, and you can, it's impossible to recognize everything. But if you filter the certain things out, it could be and could be very interesting. And a lot of people are very interesting to find the very few essential things and put in an index, like in the text. We need an index, kind of it. So, Francois, you are on the right way to identify certain parts of it which are interesting, and you can index it and get characteristics out of it that you can later make a search on it.
We have one more question here. Oh, two actually. I see another one.
To answer the processing power, hardware has always been ahead of software, and it will remain the case. There are so many developments in processing power. Actually, very soon we will, even now, I mean, our iPhone or whatever your mobile is more powerful than a desktop computer 5 years ago. So the latest research says processing power will increase almost 10-fold what we have now, plus what's been mentioned about parallelization. There's a lot of the whole cloud and clustering algorithms. Processing power will not be the issue. We're still lagging behind in intelligent software, and we will be for some time. Analyzing content intelligently, understanding what content is about, that's the challenge. Hardware will not be the issue, in my opinion.
Let me just respond to that quickly. I agree the hardware will be available to do that. The cost of the hardware to do that is always the issue. So, which is why for government security agencies, there's not a problem. But we manage one of our systems in the cloud in Asia, and I can tell you that the cost from AWS to do that is substantial enough that it calls into question the profitability of doing it. So yes, you can certainly, there will be available processing power. You can certainly parallelize this stuff. On the other hand, will it pay off? You know, if you get this level of specificity with regard to video, what's the cost-benefit trade-off of doing that, right?
I just wanted to give one metric, because I think part of this question is about it's not just there's an algorithm, there's hardware, there's so many variables, and it's such a rich area, the whole area of deep learning. it's evolving so quickly, as Francois said. I know within our research group for content analysis, we take the approach of extracting a visual signature from media and then search that signature. So that's maybe 5 megabytes per running hour of video, and the metric that we get with 64 cores running in AWS, we can search 100,000 hours in 8 seconds. Now, what you're going to get is fairly nonsensical information until you go through the process of what we can find out right now is we can say, where's the unique videos, where are the close cousins of the video, but we can't find cats or beaches yet. So, there's a lot of work that has to be done, but I think it's pretty fast, and there are many ways of optimizing further, I think. So, yeah, I can't think of many applications where right now you would, in computing, most people want to do something in under a second because that doesn't then disturb the user. But, most people would be pretty satisfied with searching, 100,000 hours in a few seconds, because that can be done.
Something that just popped into my head, an application that gets at the streaming issue too, is self-driving cars. They've got cameras that are watching what's happening, and you don't want your Tesla to ram into that semi, right? So this seems like a pretty concrete application for this technology. Yeah. What is a semi?
I think we're at a good end for the conversation, unless somebody else has other pressing questions for this panel. I would like to extend my thanks to you guys. Thanks for the presentations and the conversation.